Today, we're covering a critical topic that TIG welders must know: welding thin carbon steel. Thin carbon steel welding is unforgiving. Too much heat causes warping. Staying in one spot burns through. In this video, I'll show you step by step how to professionally weld thin carbon steel without burn through or warping. The welding machine must be set to direct current electrode negative. This ensures most of the heat goes into the workpiece. The tungsten runs cooler, the arc is narrower, and heat spreads more controllably. Carbon steel is not welded with alternating current. Alternating current is for aluminum. For thin materials, keep the amperage low and use a foot pedal if possible. As a general rule for thin carbon steel TIG welding, use about 20 to 30 amps for every 1/32 of an inch of thickness. For example, 30 to 50 amps for 1/16 inch carbon steel and 50 to 70 amps for 3/32 inch is suitable. For those using the metric system, the equivalent rule is roughly 20 to 30 amps for every millimeter of material thickness. Once the weld pool forms, gradually reduce the amperage with the foot pedal as you move to keep the heat under control. This minimizes the risk of burn through and warping. The tungsten to use for thin carbon steel is gray tungsten. Gray tungsten provides high arc stability at low amperage and helps the tungsten tip maintain its shape longer. Using a 1/16 inch diameter, tungsten for thin carbon steel keeps the arc narrower and makes heat control easier. For thin carbon steel, the tungsten tip should be ground to about 60 degrees and must be ground lengthwise. This widens the arc slightly, distributing the heat more gently. The arc distance should be kept short. If the arc distance is too long, excessive heat builds up and gas shielding is compromised. This leads to burn through in thin sheet metal. 100% pure argon is used as the gas. The gas flow rate should generally be 15 to 25 cubic feet per hour, or about 8 to 12 liters per minute. Too much gas causes turbulence, while too little gas leads to oxidation. After welding, post-flow gas should be applied for 5 to 10 seconds. Otherwise, the tungsten will oxidize. The most common filler rods for carbon steel TIG welding are ER70S2 and ER70S6. ER70S2 provides a more aesthetic and controlled bead on clean materials. ER70S6, with its high deoxidizer content, tolerates dirty surfaces better and is preferred in industrial applications. For thin materials, using filler wires with diameters of 1/32 or 3/64 of an inch is ideal. Thick wire needs more heat, bulges the bead, and makes control harder. The filler wire must always be kept inside the gas shield. Push the wire forward, pull it back slightly, and then push it forward again. If the wire leaves the gas, it oxidizes, and this oxide is carried into the weld pool. In carbon steel welding, surface cleanliness directly affects the weld quality. Before welding, oil, grease, and dirt must be cleaned with acetone. If there is rust on the surface, remove it completely with a wire brush or grinding. Dirty surfaces carry oxygen into the weld pool. This causes porosity, a weak weld, and a poor appearance. Thin carbon steel conducts heat quickly and also deforms very easily. So, do not try to complete the weld in a single pass. Weld in short bursts, stop and then move forward. This method prevents the sheet from overheating and reduces warping. Using pulsed current keeps heat input under control and allows for a narrower, more controlled weld. Excessive heat causes burn marks, wide welds, deformation, and loss of strength in carbon steel. In summary, using the right settings and technique in thin carbon steel TIG welding gives top-level results in both appearance and durability. In this video, we have explained step-by-step how to weld thin carbon steel professionally. If you found this video helpful, do not forget to like it and subscribe for more TIG welding tutorials. See you in our next video very soon.